In this problem, we'll use the addition rule and the rule for complementary events. We have blood groups and RH types for 100 typical adults. So let's see how that would look in a contingency table. Okay, so we'll have our groups as columns and our types as rows. Okay, so we have two rows. There are two RH types. The two RH types are RH positive and RH negative. Okay, and now we have 4 groups. And they are O, A, B, and AB. Okay, so let's fill in our data. We have 39 of these 100 adults who had RH positive and O blood, 35 RH positive A, 8 RH positive B, and 4 RH positive AB, and this row sums to 86. Then in the RH negative category there were 6 people with blood type O, or blood group O, 5 people with group A, 2 people with group B, and just 1 with AB, and that sums to 14. So we have a total here of 100. Let's check that. Here we had 5 and 10, that's 15, and 40, it's 55, and 45 would be 100. So this is our data in a contingency table. So we'll work several different problems using this data. Let's start with the statement that we'll use every time that I want to write. I'm just going to write it here once, but if one person is randomly selected, so out of these 100 people, if say we had 100 files from this blood typing we had done, and we had all those files there, and we randomly select one of them. If one person is randomly selected, find the probability that the person is, and then we'll just talk about these in types. So let's work our first problem. I'll just label that problem A. And so the person is, and now I'm going to use my probability notation, the probability that the person is group A or RH negative. So we're finding the probability that the person is group A or RH negative. Okay, so this OR is our key to knowing what we're going to do here. That tells us this is the addition rule. So we know this will be the probability, and I'm just going to call it A here instead of writing the word group every time. The probability of A plus the probability of RH negative minus the probability of A and RH negative. That's our formal addition rule. Okay. So the probability that a randomly selected person would have group type A is 40 out of 100. That ratio of 40 over 100. Plus the probability that the person is Rh negative Well, out of all this group, if we pull one file, the probability that that person is Rh negative is 14 out of 100, the ratio 14 over 100, minus the probability that a person is both, that's what this means, and A and Rh negative. Well, that on a contingency table is really easy to see because it's the intersection of A and Rh negative. When we gathered all the people who had group A and got those 40, notice we counted these 5 people right here. Then when we found the probability of Rh negative, we counted those 5 people again. So we're going to subtract off that double count. There were 5 people that got counted twice, so that's why we have this difference here of where we subtract one of those double counts. So 40 plus 14 is 54, minus 5 gives us 49. The ratio of 49 over 100, if we're asked for decimals, then we would write this as 0.49. Okay, so now let's work another problem using this same data. So if one person is randomly selected from this group, and I see now I have a typo up here, randomly selected, one person is randomly selected, find the probability that the person is, so my notation would be probability, group A or group B. Again, that word or indicates the addition rule. That's what we're looking for. So this is the probability. Instead of writing group again, I'm just going to use A plus the probability of B minus the probability of A and B. Okay? So now the probability of A, well, we just found that, so that hasn't changed. There were 40 people who were group A. Same as we saw in part A. In group B, let's look at our data again. We had a total of 10 people who were in group B. Now the probability that they were both A and B, well, notice I mentioned before that it's easy to see that and because it's the intersection of a column and a row. But A and B are both columns, and they do not intersect. So we would say these are disjoint events. They have no elements in common. A person cannot test in group A and also test in group B. So the probability of A and B is 0. And I could have just used this part of the formal addition rule because A and B, group A and group B, are disjoint events. Okay, so 40 plus 10 is 50, rounded to a decimal. Well, no rounding required. It terminates at 0.5 or 0.50 if we want 2 decimal places. Okay? All right, part C. We want the probability this time that one person's randomly selected. Find the probability that the person is not group A. Okay, well, this is one of those cases where we could add up all the probabilities of everybody that is not group A, but the easy thing to do is to use the rule of complements that says 1 minus the probability then that the person is group A. Because the only choices are you're in group A or you're not in group A. And all of that has to sum to a probability of 1 because that's our entire sample space. So 1 minus the probability of group A gives us everybody else that's not in group A. So that would be 1 minus, and we found probability of group A before, that's our 40 over 100, so we get 60 over 100, or as a decimal, 0.60. So that's how using complements can make your calculations much easier. Otherwise, we would have been finding the probability of everything that was not group A. Probability of group O, probability of group B, probability of group AB, but it's much quicker, much easier to use the rule of complements. So let's do another one of those with the rule of complements. Find the probability that if one person's randomly selected, they are not Rh positive. So that would equal 1 minus the probability that they are Rh positive. Much easier to find that one thing and subtract to get everything else that's left over. Alright, probability that a randomly selected person from this group is Rh positive is 86 out of 100. The ratio of 86 over 100. So we're going to say 1 minus 86 over 100, which is 14 over 100, or 0.14. So the probability that a person is not Rh positive is 1 minus the probability that a person is Rh positive, and that turns out to be 0.14.